Hello friends, welcome to my lecture on coloring of graphs. Let us consider a graph G, a vertex coloring, or simply a coloring of G is an assignment of colors to the vertices of G such that adjacent vertices have different colors. We say that G is n colorable if there exists a coloring of G which uses n colors. The minimum number of colors needed to paint a graph G is called the chromatic number of the graph G and is denoted by chi G. Now, we shall discuss an algorithm by Welch and Powell for a coloring of graph G. We emphasize that this algorithm does not always yield a minimal covering of G. Now, let us see what is the Welch-Powell algorithm. The input is a graph G. First step is order the vertices of G according to the decreasing degrees. So, we will find the degrees of all the vertices of the graph and then arrange them in the order of decreasing degrees. Now, step 2 is assign one color C1 to the first vertex, and then first vertex means the vertex with the highest degree, and then in sequential order assign C1 color to each vertex which is not adjacent to the previous vertex, that is the vertex with the highest degree and which was assigned C1. Repeat step 2 with a second color C2 and the subsequence of non colored vertices. So, we step in the step 3 we shall repeat the step 2 with the second color. Now, in the step 4 we repeat the color step 3 with the third color C3 and then a fourth color C4 and so on until all vertices are colored, and then we exit. So, let us see how we do this. Let us consider this graph. This is this graph. Let us consider in this graph you see there are 8 vertices. We have to find the degrees of each vertex and then arrange them in the order of decreasing degrees. So, degree of A1, let us first find the degree of A1. Degree of A1 1, 2, 3, 4. Degree of A2. Degree of A2 is 1, 2, 3, 4. Degree of A3. Degree of A3 is 1, 2, 3, 4, 5. Degree of A4. Degree of A4 is 1, 2, 3, 4. Degree of A5. A5 has degree you see 1, 2, 3, 4, 5, 6 and then degree of A6. So, here 1, 2, 3 degree of A7. Degree of A7 is 1, 2, 3, 4, 5. Degree of A8. 1, 2, 3. Now, let us see which one has the highest degree. You see we have degree of A7 equal to 5, degree of A5 equal to 6. So, A5 has the highest degree. So, we have put A5 at the first in the first place in the sequence. Next comes A3. A3 has degree 5. One lower than the degree of A5. So, A3 comes next. Then A7, A7 also has the same degree. We can write A3, we can write, or we can write at the second place we can write A3 or we can write A7 because A3 and A7 have equal degrees. So, A3, A7 and then after A7, A1 has degree 4. So, we have A1, then A2, A2 has degree 4. So, we have A2, then A4 has degree 4. So, we have A4, then A6 has degree 3 and we have A8, A8 has degree 3. Now, let us see how we shall assign the colors to these vertices. So, we have arranged these vertices in the order of decreasing degrees. Then we start with the first vertex A5. We assign color A1 to C1 to A5. So, C1 color is assigned to A5. Then A5 is adjacent to A3. So, then we leave it. then A5 is A5 is adjacent to A7. A5 is adjacent to A7. So, this also is left, and then A1, A5 is A1 is where? A1 is here. So, A5 is not adjacent to A1. So, we assign C1 color. Now, then A5 is let us see whether A2 is adjacent to A5 or not. A5 is adjacent to A2. Okay. So, we leave A2, then A4 is adjacent to A5. So, we leave it, then A6 is adjacent to A5. So, we also leave it, and then A8 is also adjacent to A5. So, C1 color is given to A5 and A1. Okay. Now, we have completed one round, that is from A5, starting with A5 we assigned to which we assigned color C1. We have checked all the vertices in the sequence, okay, up to A8. Now, we come back and start with A3. Okay. A3 we assign color C2. Okay. Then A3 is C, let us see which is A7 adjacent to it. So, A3 is here. Okay. A7 is here. A7 is not adjacent to A3. No, A3 is adjacent to A7. Okay. They are joined. Okay. So, A7 is adjacent to A3, and therefore, we leave A7, and then A1 has already been assigned the color A2. A2 is adjacent to A3. So, we leave it. A4 is not adjacent to A3. So, A4 is assigned color C2, and then A6 is adjacent to A3. So, we leave it. A8 is not adjacent to A3. So, we give it color C2. So, A8 is also given color C2. Now, we have completed with color C2. We go back and start with A7. A7 is given color C3. Okay. A7 is here. Okay. A7 is here. Now, we have to see this one. A2. Where is A2? A2 is not adjacent to A7. So, A2 is given color C3. Okay. And then what about A6? A6 is here. It is not adjacent to A7. So, it is also given color C3. Okay. So, A5 and your A1, they have color C1. They are colored with color C1. A3 and then A4 and then A8, they are colored with color C2, and then A7, A2, and then we have A6, they are colored with color C3. So, 3 colors are used to color all the vertices of this graph, and we see that let us now find the minimum number of colors to paint this graph. Okay. We see that A1, A2, A3, okay. A1, A2, A3 are adjacent. Okay. A1 is adjacent to A2, A2 is adjacent to A3. Okay. So, they are to be painted with different colors. So, A1, A2, A3 are to be painted with different colors. So, there will need 3 colors to paint A1, A2, A3, or you can consider A5, A7, A8. Okay. A5, A7, A8, they are adjacent vertices. Okay. A5 is adjacent to A7, A5 is adjacent to A8. Okay. So, they will be they will have to be painted with different colors. So, 3 colors will be needed to paint the A5, A7, A8 with different colors. So, minimum, and here we have used 3 colors to paint the entire graph. So, minimum number of colors needed to color this graph, okay, are 3, and there is 3. So, that means chromatic number of G is 3, which is the minimal number of colors to be used to graph the given to color the given graph. So, 3 is the chromatic number here. Now, let us so this is the so this we can say that this graph G is 3 colorable. If 3 colors are to be used to graph this color this graph, then we say that it is 3 colorable. Now, it is not 2 colorable, because we have seen it cannot be it is not 2 colorable, because A1, A2, A3 they are adjacent. A1 is adjacent to A2, A2 is adjacent to A3. So, that means they have to be painted with different colors. Now, let us see, we have to consider the complete graph K 6, okay? K 10, n in general we can take K n. Now, K n is a complete graph. In the case of a complete graph, every vertex is adjacent to every other vertex. Okay. So, if their vertices are B 1, B 2, B 3, B 4, B 5, B 6, okay, then each vertex is adjacent to every other vertex. That means, they will all have to be painted with different colors. Okay. So, 6 colors will be needed. 6 colors are required for painting C 6, painting K 6, okay. And similarly, K 10, in the case of K 10, 10 colors will be required, 10 colors for K 10, for coloring K 10. In general, n colors are required and this is the minimum number of colors, okay, chi n equal to n here, because it is a complete graph. We cannot color this graph with less than n colors. Now, let us consider this graph. Okay. So, here we again use Bell's-Fabel algorithm to paint this graph, and we shall find the chromatic number of G. So, there are how many vertices? 7 vertices. Okay. Let us find the degree of B 1. You see 1, 2, 3, 4, 5. So, it is 5. Degree of B 2, B 2, 1, 2, 3. Degree of B 3, degree of B 3 is 1, 2, 3. Degree of B 4, B 4 has got degree 1, 2, 3, 4. Degree of B 5 1, 2, 3, 4. Degree of B 6 1, 2, 3, 4. Degree of B 7 1, 2, 3. Okay. Now, let us write the vertices in according to their degrees. Okay. So, we have maximum degree is 5. Okay. So, B 1 has the maximum degree. Okay. So, we have B 1 in order of their decreasing degrees. So, then B 4, B 5, B 6 they all have degree 4. Okay. So, B 5, B 6, B 4 we can write in any order, B 4, B 5, B 6 because they all have 7 degrees. Okay. And then we have B 2, B 3, B 7, they all have degree 3. Okay. B 1 has degree 5, B 4, B 5, B 6 have degree 4 each, and then B 2, B 3, B 7 has degree have degree 3. Okay. Now, so we color B 1 with C 1 color. Okay. And let us see then which vertices are adjacent to B 1. So, B 1 B 5, B 1 is here. Okay. B 1 is adjacent to B 5. Okay. B 1 is adjacent to B 5. So, we leave B 5, B 6, B 1 is adjacent to B 6. So, we leave B 6, B 4, B 1 is adjacent to B 4. Okay. B 1 is adjacent to B 2, yes. B 1 is adjacent to B 3, yes. B 1 is adjacent to B 7, no. So, B 7 is also colored with C 1. Okay. Now, we go to B 5. Okay. B 5 be colored with C 2. Now, B 5 is here. Okay. So, B 5 B 6, where is B 6? B 6 is here. So, B 5 is not adjacent to B 6. So, we give color C 2 to B 6, and then B 4. B 4 is near adjacent to B 5. Okay. So, we leave B 4. B 2, B 2 adjacent to B 5. So, we leave B 2, then B 3. B 3 is here. Okay. B 3 is not adjacent to B 5. So, B 3 is also given color C 2. Okay. Then we come to B 4. Okay. Now, we give color B C 3 to B 4. Okay. C3 is colored with C4, B4 is colored with C3 and B2. Where is B2? B2 is here. So, B4 is not adjacent to B2. So, B2 is also colored with C3. Okay. So, thus C1 color is used for painting B1 vertex, B7 vertex, and C2 color is used to for coloring B5, B6 and B3, and C3 color is used to color B4 and B2. Okay. So, 3 colors are required to paint this graph. Okay. Now, you see B1 is adjacent to B4, B4 is adjacent to B6, B1 is adjacent to B4, B4 is adjacent to B6. So, B1, B4, B6 have to be painted with different colors, and therefore, 3 colors will be required to paint the vertices B1, B4 and B6. So, at least 3 colors have to be used, but here we have used 3 colors to paint the entire graph. Therefore, the chromatic number, which is the minimum number of colors to be used to paint the graph, is chi g equal to 3. Okay. So, the chromatic number here is chi g equal to 3. Now, let us consider this graph. Okay. So, here let us see what is the degree of B1. We have B1, B2, B3, B4, B5, B6. Okay. Degree of B1. Okay. So, 1, 2, 3, 4. Degree of B2. Degree of B2, 1, 2, 3. Degree of B3. So, 1, 2, 3. Degree of B4. 1, 2, 3. Degree of B5. So, 1, 2, 3 and degree of B6. 1, 2, 3, 4. Okay. So, there are 2 vertices B1 and B6 with degree 4 each. We can write any one at the first term of the sequence. Okay. So, we can write B1, let us write B1, then next is B6, they both have equal degrees, and then all others have 3 degree each. Okay. So, we have B2, B3, B4, B5. Okay. Now, we use color C1 to paint B1 vertex. Okay. So, for this we use C1 color. Now, B6 is here. Okay. B6 is not adjacent to B1. So, C1 is used to paint B6. Okay. Then B2 is adjacent to B1. Okay. So, we leave this. B3 is also adjacent to B1. So, leave this. B4 is adjacent to B1. So, leave it. B5 is adjacent to B1. So, leave it. Okay. So, B1, B6 are painted with C1 color. Now, we go to B2 and paint it with C2 color, and then B2 is here. Okay. B2 is B2 and B3, they are not adjacent. Okay. So, C2 color is used for B3 also. Okay. And then B2 is it adjacent to B4? Adjacent to B4, yes, B2 is adjacent to B4, B2 is adjacent to B5, no, B2 is not adjacent to B5, okay, B5 is here. So, this is also painted with C2 color. Okay. And then what is left? We are left with B4, okay, B4 is painted with the color C3. Okay. So, C1 color is used for B1, B6, C2 color is used for B2, B3 and B5, and C3 color is used for B4. Okay. So, 3 colors are used to paint the vertices here. Now, let us see what is the chromatic number. You see, we have B1, B2, B1 is adjacent to B2, B1 is adjacent to B5. Okay. So, 3 colors will be needed to paint B1, B2, B5. Okay. And here we have used 3 colors to paint the entire graph. So, chromatic number means minimum number of colors to be used to paint the graph. So, chi g equal to 3. We cannot paint the graph with colors less than 3 because B1, B2 and B5, B1 is adjacent to B2 and B1 is adjacent to B5. Now, let us consider this graph. Okay, so consider graph, use the Bell's-Fabel algorithm here. So, degree of, let us write degree of B1. What is degree of B1? 1, 2, 3. Degree of B1 is 3. Degree of B2. Okay, degree of B2 is how much? 1, 2, 3. Degree of B3, 1, 2, 3. Degree of B4, 1, 2, 3. And degree of B5, 1, 2, 3. And degree of B6, 1, 2, 3. Okay. Okay, B6 also has degree 6, 3. Now, so they all have degrees 3 each. Okay. So, B1, B2, B3, B4, B5, B6. Here B1, let us start with B1. We can color it with C1 color. Now, B1 is adjacent to B2. So, we have to leave B2. Then B1 is adjacent to B3, we have to leave B3. B1 is adjacent to B4. No. So, B4 can be colored with C1. B1 is adjacent to B5. Yes. B1 is adjacent to B5. So, we cannot color B5 with C1. B1 is not adjacent to B6. So, we can color it with C1 color. Okay. Then we go to B2. B2 can be colored with C2. Then B2, is it adjacent to B3? No. So, it can also be colored, B3 can also be colored with C2. And then B2, is it adjacent to B5? B2 is not adjacent to B5. So, it can be colored with C2. Okay. So, C1 color is can be is used to paint B1, B4 and B6. Okay. And C2 color can be used for B2, B3 and B5. Okay. So, 2 colors are required. And you see we have B1 and B2, they are adjacent to each other. So, we will have to use different colors to paint B1 and B2. So, 2 colors are needed for painting B1 and B2, and here we are using 2 colors to paint the entire graph. So, minimum number of colors to be used to paint this graph, that is chromatic number, is 2. So, that is the end of this lecture. Thank you very much for your attention.